Well, hello there. My name's Dr. Laughlin, for those who don't know me, and I'm one of the science teachers there at Roseville College. And the point of this short video is to give you some feedback on your recently completed IRP project. Now, first of all, we should just say a big congratulations. This wasn't an easy task to do. It's your first independent research project after all, and speaking to some of the other science teachers who are currently in the process of marking them, we are so far very impressed with the quality and I guess the extent and depth that some of you, if not most of you, have gone through to produce a really high quality poster based on really good science. However, there's always ways we can improve, so we're just going to go through a quick little run through of all the different ways people might have missed out on some marks, as well as some helpful tips for next time, because this won't be the only IRP that you do during your schooling career. Yes, unfortunately, some of you probably don't want to hear this, but you will be doing another IRP, but not until year 10. So whilst that might seem like a long way away, what I'm about to say would be very beneficial to not only completing that IRP, but also along the way you'll get to pick up some of these skills in other assignments and projects. So let's begin. So firstly, by way of general feedback, like I said before, myself and some of the other science teachers who are marking your reports are very impressed by how much depth and effort that you've all put into making these posters and undertaking the research during class. There are some kind of overall sort of feedback where most people kind of weren't able to sufficiently demonstrate these skills, and they included things like scientific literacy. Okay, now, scientific literacy is more about how do we actually write a scientific paper. So you will imagine that it would be very different to how you might write an essay in English, for example, or how you might write a response in mathematics. So scientific literacy is something that we have to practice, and it takes a long time to get a hold of. So it's no surprise there that a lot of us might not have had the best scientific literacy as yet, because you're only in year 8, and this was your first IRP. The next kind of common pitfall that I found particularly was that when we were writing our background or introduction sections, we failed to kind of link the really great information or research that we found. We failed to link it back to our specific hypotheses or questions. Okay, now that usually just looks like a final sentence saying, and for these reasons, I've chosen to investigate X, Y, and Z. Okay, I'll show you a little bit more how that might look in terms of paragraph structure, but that's just a common pitfall I found. And thirdly, there were lots of really great scientific explanations given. However, we tend to just say them and not actually refer to any sort of authoritative figure or reference that might back our statements up. So this is all about referencing our statements in our work, and again, I'll talk a bit more about how we might do that. But again, don't worry too much if you weren't able to do this. This is all very new, probably to most of you, so it's just part of being a better scientist, I guess. So there were 3 main areas that I found that people were generally lacking in their reports or posters. What I want to do now is just go through each of the different sections and highlight what people did well, and kind of eyeball things which might not have been ideal or ways that people could improve. So the first section of your poster was your aim and hypothesis. Okay, so I remember telling my students in my classes that the difference between an aim and hypothesis is, well, an aim is just an overall objective, okay, usually stated as a question, whereas a hypothesis is a statement or a prediction. Okay, so for example, the aim is usually broad and includes both the independent and dependent variables. Okay, whereas the hypothesis is a specific statement which also has a reasoning behind this prediction. Okay, and they're usually very short and precise. Okay, we don't like to waffle on, because these are the kind of just really clear objectives and purposes of the study. Okay, now for us in Year 8, we did two of these things really well. We were able to make a great aim, which included both the dependent and independent variables, and we were also able to state a prediction. However, what most people failed to do is then actually provide a reasoning behind that prediction. And to explain what I mean by that, I'm just going to go through some examples of what I think are good aims and good hypotheses. Okay, and I'm going to use the example of our physics project, that is looking at how speed varies with the slope of a ramp and mass of an object. So, for example, if we had the aim as being to investigate the effects of changing weight and slope on the speed of a toy car down a ramp, okay, seems very wordy, but it works, we would first see that we have both the independent variables, which there's two in this case, that is weight and slope, as well as the dependent variable, which is speed. Okay, so rate aim, okay, includes both the independent variables and dependent variable. Okay, now it's not framed as a question, but that's okay. It's showing it basically what our purpose of the overall project is. Okay, then if we wanted to create a hypothesis out of this aim, we're going to turn it into a statement or a prediction. So for example, as weight and slope increases, so too will the speed of the car because of increasing gravitational energy. Now the point here that I try to highlight is we don't only just provide a prediction, but we also have a short little statement as to why we think that will be so. Okay, so in this case it's because of the increased gravitational energy associated with having more mass and a greater gradient. Now for those of you who might have done the physics topic, I just want to have a word of particular feedback. So a lot of you, instead of using the word slope or gradient, you use the word height. Now, whilst this might seem quite pedantic, I'm just highlighting this as an example that in science we need to be really precise, and this comes back to our scientific literacy skills, because what we mean by height and I might not necessarily refer to slope or gradient. And to explain what I mean by this, let's consider if this was your ramp, okay, and you had your different objects which are rolling down a ramp at different heights. So for example, this object here is at a height of 10 centimeters, and this object here is also at a height of, is at a height of 5 centimeters. Now they're at different heights, can you see? However, the slope is still the same. So if the hypothesis or prediction was stated that a ball or a cylinder or an object at different heights would travel at different speeds, well, you might be right, okay, but it wouldn't actually be the question that we actually done in our experiment. Another way this word height can be confusing. So imagine if we did the experiment on the floor, okay, we still had the same gradient, okay, and we can change the height of the whole experiment, so we put it on a table, okay. Now in this case height has changed, but the gradient or everything else is the same. Do we think there's going to be much difference in these results? I don't think so. Okay, so basically the reason I'm harping on about this is because slope or gradient is quite different to height of the ramp, as hopefully you can see now. Okay, so we basically looked at the angle that the board was changing. Okay. All right, so that's all the information or feedback I'm going to give in terms of the aims and hypothesis. Now we're going to move on to the background information, or sometimes referred to as the introduction section. Now, the overall purpose of this section, and I got a lot of questions about this, what do I include in my background information? What do I do? What do I do? Well, firstly, it should provide a rationale or purpose behind the study. We don't just do science for the fun of it, or some people do, but generally there are lots of money needs to go into this sort of thing, is we need to justify the importance behind our research. So first and foremost, the background is to kind of say why you did the study in the first place. Why was it important? Okay, and a lot of us did that. Okay, a lot of us are really great at kind of highlighting the big, broad theme, but unfortunately, might have just left it there. The next bit of feedback I would include that you need to have references, and I'll talk a bit about what's called in-text referencing at this in a little while. But you need to kind of support your statements with scientific studies or references. And thirdly, it needs to link, so the background information needs to be relevant and needs to link back to your hypothesis. Okay. This is generally comes at the end of the introduction, after you've kind of laid out your arguments. You say, and therefore this is why we undertook the experiment to test X, Y, and Z. Okay, and finally, it should have a nice logical flow. Okay, going from what I'll talk about in a minute, from a really broad entry level into the topic, right down to the specific questions that you'll be asking. In terms of what it shouldn't have, a lot of you at this stage, because you haven't really had experience writing scientifically, a lot of you will just kind of include like random facts or what you think's important definitions, which is great. However, you need to work this into a paragraph that has a logical flow. You can't just put dot points and expect the reader to see where the connections lie or see why you've put them there. You need to be explicit. So yeah, that's the only kind of negative feedback I'd give for the background information. Generally, this was done quite well, and you could see the larger or bigger picture. Okay, and generally, another note at this point: the background research generally comes first in a report and on the left-hand side of a poster. So it's giving the reader the background information, so they can kind of look at your results with more of an informed and up-to-date opinion. Now, I'm just going to go through exactly, if you're going to write an introduction or a background section again, this is how I would attack it. I would kind of structure it in this, what I call upside down prism, okay, where the first sections are broad and it kind of gets narrower and narrower down to till it gets really specific. Okay, so the first part of any introduction or background is to start with a broad topic. So for example, we might be thinking about how climate change is affecting food security, that is, the amount of food that we can make and give to each other. Okay, so that would be the broad topic, and we might put in some scientific studies which have shown that this is a problem. Okay, then, well, that's a very big issue, okay, like food security, climate change. We could go do anything with that at this stage. So we need to start narrowing down our perspective. So this is where we introduce our specific issue. Okay, so for example, still looking at climate change and food security, we might start looking at a particular section of that problem or that issue. So in particular, we might have found that, as we've done our research, that the frequency and intensity of droughts within Australia particularly have increased the risk of depleting food supplies or something like that. Okay, so you can see how now I'm just slowly chipping away, getting narrower and narrower. But still, this is still quite broad, okay? So at this point, you might want to say, well, this is the problem. What are some of the solutions that I myself or some other scientists are proposing that we should do to tackle this problem, okay? And that's next step, propose a solution, okay? So in this case, we might want to understand how much water do we actually need to grow certain crops, and if we need too much water, then should we use other crops which don't need a lot of water and therefore be more environmentally sustainable and those sorts of things, okay? But I yet to have got to my final specific statement, which will relate it straight back to my hypothesis, which is my aim, okay? So once we've done introduced the broad topic, the specific issue, and then provided a solution or potential solution at this stage, then we're going to go talk about our aim. Okay, so link all this information back to our aim. So for example, the aim of this study might be to investigate how different amounts of water influence plant growth. Okay, so that's what we would do to formalize our introduction. Now, I did mention that throughout an introduction, as well as a discussion, by that matter, you need to be doing what's called in-text referencing. Okay, so this is an example of a bad version of an in-text referencing where there's no sort of indication of where this information came from. So, for example, if we were doing a science project on Galileo and his initial discovery of orbiting planets around the Sun, someone might say, my research showed that the Earth revolves around the Sun. Okay, well that might be true. You might have gone on and researched the latest, the best scientific journals or websites, whatever it was. However, we don't know that. Okay, from this statement, all it says that you just kind of potentially decided, oh yeah, my research, I spoke to my old nanny or my grandma, and she tells me that the Earth does revolve around the Sun. So I took that as valid because she's been around a long time. Okay, so this, whilst I'm kind of making this a bit of a joke, this does happen. We sometimes forget that, all the information that we take for granted did come from someone. So whilst I don't want you to worry about having to reference every single statement you say, okay, for most statements I want to see in the future some form of reference to a scientific journal or article or website at least. Okay, but as you get through your science lessons in the coming years, we'll teach you how to find these journals as well. So just don't stress out too much just yet. All right, so then we might move on to a second version of this one, which is still, it's better, but still not perfect. Okay, so for example, we might attribute this claim to Galileo. So Galileo demonstrated using his telescope that the Earth revolves around the Sun. Whilst this is true, it's still a statement which has been unconfounded. So that is, it hasn't been supported by any reference, so to speak. Now, the best way that I would do an in-text referencing would be something like this, okay? So according to Jones and Smith, 2017, Galileo used his telescope to show that the Earth revolves around the Sun. Now what this does, it doesn't only just say the same information, but it actually ascribes those facts to a particular author or authors, okay, who have done extended work, or their paper has been peer-reviewed, or they're just credible sources and they know what they're talking about, unlike potentially our nanny from next door. Okay, now this isn't the only way we can do what's called in-text referencing, okay, whereas we say Jones and Smith in brackets 2017, we can also just say the statement, okay, like this: Galileo used his telescope to show that the Earth revolves around the Sun, and then in brackets we can say Jones and Smith 2017. Okay, now there's a couple of sort of like technicalities which you don't need to worry about too much, and we didn't take marks off in your IRP if you didn't do the correct in-text referencing. I'm just going through this for future reference, so you can just start to build up your scientific literacy skills, so to speak. So in terms of being able to modify how you write these in-text references, depending on what sort of article or paper you're looking at, the first thing to know is that if there's more than two authors, instead of saying Jones, Smith, George, and all the other authors, potentially up to 50, who knows, you just say the first name, last name of the first author, followed by these two little words, et al., okay, which means and all, okay, and then you have the year that the publication was published, okay. So there are only two steps that I would kind of recommend to you at this point. And we can talk about more that we can talk about this sort of style more in class, okay? However, this is just the reference inside the text, okay? You would then, in your reference or bibliography, have to provide a full reference or full text reference of this text, sorry. And that would look something like this. Whoa, very tricky. Okay, so let's break this down just for a moment, okay? So if this was a journal article, okay, which potentially it was, I've just made it up, you'd have the authors, their names would come first, where you kind of just use their initials, potentially. Then we'd have the year of the publication in brackets, followed by the title of the article. In this case, I've just made up a fictitious name. How Galileo used his telescope to investigate the orbits the orbits of planets. Okay, then after that, we want to show where was the source, where was the journal that we found it. Okay, well, in this case, I made up a name, the International Journal of Space Exploration. Sounds pretty fancy. Okay, but this journal might have lots of different volumes and lots of different issues within volumes, and then we need to know what exactly page within each volume. So therefore we put this, which is the volume, the issue, and then the page numbers. Okay, and this would just be for one reference. You then have to have all the references in this big bibliography or reference section that you cite.